So again we are here with one more topic, okay, and the name of the topic is decomposition reaction. Okay, so this is the second part of the video called types of reaction. So we have simply understood what is the type of reaction in the first case, okay, combination and synthesis reaction, and you all have showed a huge support towards my video, and you have commented, you have liked, you have shared. Okay, the name of the video is decomposition reaction. So we will complete also this one with very useful examples, with the reactions, everything. So without wasting the time, let's get into the chapter. So thank you for all the students who has responded to the video that I have uploaded. Okay, that was combination of synthesis. So it's a decomposition reaction. Okay, what do you mean by decompose? Means breaking down. Okay, if anything get more simple substance, okay, that is known as decomposition, which we know in simple terms. Okay, any given compound. What is mean? Decomposition means to break down any given compound into a compound. Always remember, a compound will break down. Okay, compound will break down into, it can be two new elements, it can be two new compounds, it can be an element as well as a new compound. Okay, always remember, the compound is going to break down. Okay, the compound is going to break down. Okay, always a compound will going to break down. It will give you, it can be two elements, it can be two compounds, or an element and a new compound. Always remember this one. So it is just opposite to that of a synthesis or combination reaction, which I have explained in the last class. Okay, simply opposite of that one. So we'll see with an example how it will give you elements, compounds, or element and compound. Okay, now so if you will see two elements, na, this is a compound, this is a compound, it's a compound. Okay, so when I am providing the heat to this compound, what is happening? It is getting broken down into two elements, two new, these are elements. Give you two elements. Okay, next give you two compounds. So again a compound will break down into two more compounds. Okay, element and a compound. Break down, you're getting an element as well as a compound. Okay, so you understood how it's happening. Okay, these are the three cases which are going to get. We are going to get the element we'll get the compounds we'll get, and we'll get the element as well as a compound. Okay, element as a compound we'll get. Okay, element and compound. Okay, so these are the three things which are going to get from a compound only. So always the reacted side is a compound and the product side can be a compound element, or it can be element as well as compound. Understood? What I'm going to get, first we have to understand what are the things we have to, in the reactant side only we have compounds. In the product side can be element, can be compound, can be element and compound. You understood this one? Yes, we have understood, sir. Now sir, tell us that decomposition, the breaking down. So breaking down doesn't involve, it doesn't happen of its own. It requires something. It requires heat, light, energy, anything it requires. So explain more about that also. Okay, I will explain that one also. So you understand what we have and what we are going to get. So reactant side and production. So if you will see, simply it is opposite to the combination reaction or synthesis reaction which we have saw in the last video. Okay, so next one. Now this is the first reaction we will see regarding the heat of ammonium dichromate. So we know ammonium dichromate is this one only. So we are passing the heat over this one. Okay, we will give a symbol of delta, means heat. Okay, we are passing the heat, and because of that we are getting chromium oxide. Okay, and water and nitrogen we are going to get. So if you'll see, okay, this usually takes place in volcanic eruption time. Okay, this usually takes place in, so because of this reaction we are getting the nitrogen, and this nitrogen, okay, which is formed, causes the eruption, okay, in the volcanic, okay, and they changes the color. So if you'll see, we'll take in the ammonium dichromate, which is orange in color. Because of the reaction it went green in color. Okay, so here we are getting nitrogen, okay, and the chromium. Okay, so chromium is being expelled out, okay, and the nitrogen is responsible for the eruption in the volcanoes. So now hydrated substance. Now we will heat the hydrated substance. What do you mean by hydrated? Means the one which consists of a water molecule as a part of its structure. See, this one is water is also there along with this one, CuSO4.5H2O. So this is having water along with them. That is known as water of crystallization or hydrated substance. Hydrated substance means the one which is having water along with them as a part of the structure. They are known as water of crystallization. The water of crystallization or hydrated substance means this one only. Okay, so that is 5H2O. So there is a water of crystallization. Now we have to pass the heat in this water of crystallization. So we have to pass the heat in this one. So when the heat is passed, what happened? It will break down. So decomposition, break down into CuSO4.5H2O. Okay, means the water molecule which was there, okay, as a part of this one, because of that it is known as water of crystallization, they got removed. they got separated. Okay, so the previously the color was blue in color, that's why it is known as blue vitriol. Very important name, this is known as blue vitriol. It is blue in color from this name. Why this, from where this color came? Because of this water of crystallization. Whenever water of crystallization is there, means 5H2 or 6 or whatever is there, so they will give you the color of this to the salt. This salt, because of this it gave this color to a blue color. So when I am passing, so they are broken down. So because of this water molecule, what I told you, the color is this compound is having a color. Okay, so now when they are separated, so now it will have a color. So no color, so that's why white. No anhydrous, okay, anhydrous, no color. When it will again, it will come in contact with this one water molecule, again it will become colorful. Okay, so water is responsible for the color of this compound. Okay, so you understood this is a decomposition. Now sir, for example, if I will further decompose this one, if I will continue to pass heat on this one, so you're going to get copper oxide, sulfur dioxide and oxygen. Okay, if you want, you can write the reaction. Okay, when CuSO4 is you have excess, you are passing that. For example, up to certain limit I am passing that, I'm going to get this two. But again, if I am trying to pass, the more heat is passed in this one, so I'm going to get copper oxide, sulfur dioxide and oxygen I'm going to get. And this is white in color, and the copper oxide which I am going to get is black in color. You can write in that equation, black in color, and the sulfur dioxide which I am going to is a pungent smell, I'm having. Okay, so you understood. So up to here understood what I am going to get is a decomposition. Again, see, a compound, okay, gives you two other compounds. Decomposition is very important. Blue vitriol, okay, and so white, why you are getting, because white in color. What is hydrated? I explain you what is water of crystallization, what is anhydrous. You understood. So anhydrous means not have any water molecules. Okay, water hydrated means have a water molecules, or water of crystallization means water molecules are part of the structure. Because of this water molecule, it's getting the color. Okay, so different water molecule, number of water molecules will be different, so color will be different. No water molecule, the no color. Okay, so it become white. As I told you, because of this water molecule, it is blue in color. No water molecule lost its water molecule, so it become white. So when you further divide this one, you will get copper oxide, which is black in color, and sulfur dioxide, which is pungent. So now we know what is decomposition. So here something else also they told you, dissociation. Now after watching this one, I have understood there is a great difference between dissociation and decomposition. So thermal decomposition, thermal dissociation. What do you mean by that one? First we have to understand this one. After that we can go into the chapter, because some of the places it is in dissociation instead of decomposition. So they are not same, they are both are different. So we need to understand that one. What is the meaning of decomposition? What do you mean by decomposition? Irreversible reaction. So what do you mean by that one? I will tell you. Reversible. Reactant will give you product, will not get back the reactant on cooling. But when your reaction is happening, you will get the products. On cooling, you will get back the reaction. Both takes place with the heat. Decomposition, dissociation, both takes place with the heat. Means what? It will break down by the application of it in both the cases. Okay, so if you see this example, when I am applying the heat on this one, calcium oxide and carbonate, if they will again, if I will cool down, they will give me again calcium carbonate? No, sir, will not give you. So it's irreversible. Okay, so from reactant to product, I am going to get both with the application of heat. So decomposition. In this case, when I am providing the heat to this one, it is giving me ammonia and hydrochloric acid. But when we will combine, I will get back the ammonium hydroxide again. So it's a reversible process by the application of heat only. So reactant to product, we are when we are cooling the product, we are getting back the reactant. Understood this one? Yes. We are getting the two things. Okay. So when we are heating, we are getting this part, and we are cooling back, we are getting this one backside. So this is also some of the examples of thermal dissociation. This is decomposition. So there is a great difference between dissociation and decomposition. Understood? Okay. So the next is electrolytic decomposition. What do you mean by electrolytic? Means passage of electricity. When you will pass electric current, okay, it will decompose. I told you it need energy to decompose. To decompose, it need the energy. So I will pass the electric current. So because of the passage of electric current, it will decompose into hydrogen and water, oxygen. So this is a water. I am passing the electric current. So what is happening? I am getting hydrogen and water, oxygen I am getting. This is a water. When I am passing the electric current, I am getting hydrogen and oxygen. So this is what electrolytic decomposition is. Decomposition breakdown by using of the electric current, electrolytic. Just like thermal heat. Okay. Now here they have written some acidified. So what do you mean by acidified? Means some amount of acid is added into this water. Okay, why sir it is added? So that it will help in conductivity, so that electricity can easily pass into that, so that they can easily break into ions. So because electricity passes easily, okay, into this and break them into two individual things, okay, individual elements. So that's why we are adding some acid to the water. If normally we will pass the electric current, it will be difficult to break down. So that is known as acidified water. Okay, so this is a reaction where we get the decomposition by passing of the electric current or electricity, that is known as electrolytic decomposition. So you understood this one? So there you go, there's the next thing. Photochemical decomposition or photolysis, or photo decomposition. Photo means the light, the passage of the light or the presence. So in the presence of the light any decomposition is taking place, that is known as photochemical decomposition, photolysis, या फिर photo decomposition. Okay, so there should be light. So if you see silver chloride, this silver chloride, there is the next thing. Photochemical decomposition or photolysis, or photo decomposition. Photo means the light, the passage of the light or the presence. So in the presence of the light any decomposition is taking place, that is known as photochemical decomposition, photolysis, या फिर photo decomposition. Okay, so there should be light. So if you see silver chloride, this silver chloride, silver bromide are very sensitive to the light, so easily break down. So silver chloride, when the passage in the passage of the what we say light, okay, photon means light only, light energy will give you silver and chloride. H2O2 hydrogen peroxide will give you water, and some more examples are nitric acid will give you nitrogen dioxide, oxygen and water, and if oxygen is there, so and benzene is there, they will give this one. So these all are photosensitive, means they are when they get the light from the sun, okay, or any from reaction will get from the photo energy will get, so they decompose into this one. Okay, so that is known as photochemical decomposition, photolysis, or photo decomposition. So everywhere photo you will see. So photo means what? The presence of the light, the energy of the light, because the photons we say, the light energy which we get, we say photons. Okay, in the higher class you will read. So because of that energy they decompose into individual compounds, elements, or elements and compounds. Next is decomposition reaction in metallurgy. So all this we are doing to get what? Metal. Okay, to break down anything. Okay, so decomposition means breaking down in the metallurgy. Metallurgy is very important process for what? Extraction of metal. So get the metal from its. What do you mean by ore? Ore means just like see, for example, this is a calcium carbonate. It's an ore. We need only calcium. We doesn't need calcium carbonate. Okay, just like for example, okay, we need calcium, only calcium. So what we have to do? We have to remove this carbon, CO3. So that is the process known as extraction of metal, or we say metallurgy, where we'll only need the metal, okay, from its ore. Ore is from where it is extracted. Okay, so that can be done by various methods. Extraction of metal from its ore. Okay, we'll take a ore, from there we'll get the metal. Okay, or electrolytic decomposition, just like this one you see, this is the ore. Okay, we metal carbonate we have taken. Okay, we are passing the heat, so we are getting what? Metallic oxide. We are getting metallic oxide. We are not getting metal. When the heat is passed, we are getting metallic oxide and carbon dioxide. Sir, we need metal, we are getting metallic oxide. So you said we are getting the metal. Again you have to process this metallic oxide, then you will get the metal. It took 2 to 3 steps. Okay, so now it's not there, that much is not there for your course for now. Okay, so now you understand, okay, whatever is needed for you. Okay, next, electrolytic decomposition. So here we will use sodium chloride, can be easily done by this process, okay, to get the metal. Next, refining of metal. In this, copper and silver can be used to get the refining of metal. Refining of metal, we can use copper and silver in this case. And decomposition of oxide, mercury oxide we can use. Decomposition of silver salt, silver chloride we can use. So these are some of the methods which are used in metallurgy to get the metal from their ores by many methods. These are the methods. Okay, so there is no need to go that much deep. Okay, in your book sufficient amount, there is no need to go that much deep. Okay, you understood this one. What I am trying to say, metallurgy means getting the metal from the ore. There are many methods which we can use. Okay, there are many methods which we can use, and if you need a detailed explanation on the metallurgy, okay, how they are working, if you comment me down, okay, in the comment box, I will make a video on this only metallurgy, how this process works, this one, everything I will explain you with nice example, with equation. Okay, so you understood this one, how the decomposition takes place in the metallurgy to get the metal. Okay, we have successfully completed the part 2 of the topic called types of reaction, where we have discussed the decomposition reaction. Okay, and I have given all the reaction with example and many things I've explained you. Okay, they are very important notes. You need to copy down everything from the video that I have forwarded to you. Okay, so if you like the video, please like, and again you fill all the comment box. If you need any more notes regarding the metallurgy, as I told you, if you comment in the box, I will prepare the video. And one more thing, don't go back. Okay, one more thing is there. So this is not yet completed. Decomposition reaction, there are many exceptions we have. Okay, so I'm not including that exception in this video only. There's the next video will come with the exceptions. Okay, where I will explain how the exceptions work and what is and what reactivity is. The reactivity is very important. Okay, for everyone. Okay, so up to here you understand nicely. Tomorrow I will come with one more video where I will explain all the exception, all the reaction takes place in the reactivity with respect to that.